All right, thank you everybody. Thank you for sticking it out to the last session of the day. Hopefully it'll be the best one that you've seen here. In fact, I guarantee it. My name's Clinton Herget. I work for a company called Sneak, which is a developer security platform, and it is pronounced sneak as in a pair of sneakers or sneaking around, like the bad guys that we're trying to thwart. It is also an acronym. It stands for So Now You Know. So now you know that much at least. And today we're here to talk about security in the modern software supply chain. And we'll get into exactly what that means and why we should care about it. As for me, I spent about 20 years building software for a living. I now get to talk about building software for a living, and that's a lot easier for a lot of the reasons that we're here to talk about today. So what we're going to cover really quickly is sort of what is the software supply chain? Why are we talking about it? Why is it a subject of so much concern? Why do we care about securing it, and go over some of the attacks that can actually be orchestrated against your software supply chain? What are the risks that are associated with it? And in fact, why aren't we paying enough attention to those risks when we're addressing software security in general? Finally, what can we do about it? And in fact, we're going to see we're pretty limited as of today in terms of the tooling and the processes that are available to address these software supply chain risks. But what should we be doing? What world could we eventually be living in where software supply chain security is effectively mitigated, and what changes are needed to get there? And then I'd like to talk a little bit about developers and what role the builders of software have to play in this brave new world where software is getting exponentially more and more complex every day, and therefore, unfortunately, less and less secure. So why are we even talking about the software supply chain, right? And actually this goes back really over 10 years ago now. If you were around at the time, 2011, Marc Andreessen had a very famous op-ed in the Wall Street Journal where he said, software is eating the world, and in the future there will be no such thing as a non-software company. Well, it's eaten it, and here we are, and there is no such thing as a non-software company. If we look at the kinds of organizations building software today, it's everyone. There's no such thing as human activity on the planet Earth that is not mediated by software. That's the world that we live in. And those applications are now critical to all processes that we interact with as human beings, but be it taking a ride from point A to point B, getting food delivered to my house, sending money to my friends, buying things online, getting my groceries, communicating with my coworkers. But that obviously has relied on a lot of change that's happening over the last 10 years, right? We're here at an Amazon conference, and if we had been at this same show at 2011, first of all, there would have been no such thing as the cloud, right? There really wasn't an idea yet of DevOps, of software delivery that is automated. There certainly wasn't a concept of really agile software development, right? Everything was based in waterfall, this really stop and start approach of building software and then securing it, focusing really on securing the artifact rather than securing the process that is used to build the artifact. And you can see this rapid complexity increasing in the way software is built and the kinds of tools and processes that are involved in the building of it. Back in that, yesteryear, it was actually a relatively simple process where a bunch of developers got together and they wrote application code. It was almost all proprietary. They took the artifact after that was built by a compiler and they installed it on some servers. They probably just opened up their FTP client and copied those files over. The people managing those servers worked in the same building, probably in the basement in the data center, where their job was racking and stacking machines into metal racks and plugging in network cables and so forth. And they were maintained, right, over time. Everyone who touched that software worked for the same organization and probably in the same physical location. Every line of code in the application was written by somebody who works for that same company. We don't live in that world anymore. Software is not deployed once every few months. It's deployed every few seconds. It's not deployed by opening an FTP client and copying some files. It's a continuous integration pipeline that takes a Git commit and initiates a build process in a container that's running on a Kubernetes cluster that ultimately deploys it out to the cloud. Along the way, you're going to want to check that for security, right? So you've got a static analysis scanner, you're scanning for your open source dependencies, you've got to scan your container for those potential vulnerabilities. You probably want to check the code to make sure it's linted correctly, right? That you've got the right amount of coverage, even the right comment density. Anything along the way that triggers an alarm, well, there's an automated process for that too, right? It opens up a Jira ticket, it brings it back to the developer. And I just mentioned about 40 tools that are now involved in these increasingly complex life cycles of software. And that complexity has increased to the point that nobody is in a position to even understand how many tools are involved in these build processes. The most alarming aspect of all this, though, is that the hands that are now touching the software, the vast majority of them aren't part of the organization that's building the software. They work for somebody else. Maybe they're open source developers. Maybe they work for a vendor that's providing some critical component of that continuous integration pipeline. Maybe they work for a cloud service provider. But each of those pieces of software was also built by this same kind of model, right? And so you eventually have this infinite complexity scenario where no one and no set of tools is in a position to guarantee how many hands have touched that piece of software before it reaches the production environment. And that's a feature, not a bug, right? That is the DevOps principle that we're all living by. Rather than software development being this straight line from development to production, we now have this infinite loop, right? And software is continuously being deployed and continuously being worked on and continuously being scanned for security. But each of those steps involves this continuous impact of, hundreds, if not thousands of tools in an ecosystem, often with little to no visibility from the perspective of somebody whose responsibility is securing that software. So it's the very philosophy that enables DevOps, that enables cloud and agile software development at scale, that leads to this sort of untenable complexity problem. So that brings us to the software supply chain, right? And if I were to ask that to the audience, I think everybody would have a slightly different definition. So let's maybe back up a little bit and ask, what is a supply chain in general? It's easier to think about when you're addressing something like an industrial commodity, a physical product in your hand that you go and buy from a retail store. That starts from some raw materials, right? There are companies that extract those from the natural environment. They are supplied by other kinds of organizations that have employees that work for those organizations that touch the raw materials. They then get taken to a factory, right, where a series of machines work on them and refine them and generate components that are then assembled by other machines into products that are stored in a warehouse, that are delivered by trucks in a logistics ecosystem, and that finally make it to that retail store for you to purchase as the consumer. Now, of course, this entire system relies on trust, right? The retail store has to trust that their deliveries arrive on time, and the warehouse has to trust that they're getting the right products from the manufacturer at the right times, and that their raw materials are of a certain level of purity, and that they're perhaps extracted from a certain place. But a lot of that trust is actually explicit. It's spelled out in the contracts between these various companies, and that is why when there is a recall on a product because E. coli is found in spinach, we know exactly which batch and exactly which lot number and exactly which stores they were sold in. The government recognizes an interest in tracking these trust relationships between companies when it comes to consumer products, precisely for the reason that complexity in supply chain introduces risk, and the government takes an interest in protecting consumers from those risks. Now let's maybe compare that to what the software supply chain looks like. And again, we're talking about a set of materials and tools and platforms and people involved in the building of software. Let's call it a software factory. Modern software is distributed, much like the modern industrial supply chain, right? There is no one organization that builds all of its software from scratch. Most of it comes from somewhere else. I'm a developer. I want to open up a file on my desktop computer, which, by the way, is full of software, probably that my organization doesn't know about. I open that up in an IDE that is full of plugins that were all built somewhere else by people I don't know. That's touching my code. I write a file. I probably include some open source dependencies to do the undifferentiated heavy lifting of things like allowing somebody to log in, of making HTTP requests against the server, for example. I don't know who wrote that code. I certainly don't know who wrote the code of the dependencies of those dependencies, right? And you can kind of run this ad nauseum. I probably put that application into a container which has more dependencies, hundreds or thousands of Linux packages living under the hood. I kind of trust that those are mostly okay. I pulled it from Docker Hub, right? So that must be secure. I then make the commit. I take that file and stick it in a Git repository that lives in the cloud where it's maintained by somebody else with a supply chain that I don't completely understand. That then kicks off an automated process involving a continuous integration pipeline with build tooling, with environments that have their own dependencies and their own supply chains, each of which touches my applications in ways that I can't see or verify. And on the other end comes an asset. It's my software. It's built into a container. I probably take that and I stick it in some sort of registry or an artifact repository where it's stored. I don't have visibility into who's able to interact with that, by the way. I just trust that, it's okay, so that when I pull it out, when I deploy it into production for access by a consumer, I'm assuming that nothing's changed along the way. The problem, though, and the difference between the software supply chain and the consumer product supply chain and industry is that the trust relationships are implicit. There is no explicit relationship between me and GitHub around what's in their software and how it's interacting with mine, or AWS, or Circle CI, or any of these tools and all the plugins and the API architectures that stitch them all together in ways that ultimately accelerate the speed of software into production. The other key difference is why it might take days or weeks or months or years to actually get a consumer product from a raw material all the way out into a retail store. This supply chain takes place in seconds. And that critical piece of software that I started on my desktop is suddenly deployed at planetary scale to anyone who wants to use it without anyone checking along the way what happened to it or able to verify that the asset that actually got deployed is the one that I care about and what's put into production. So why focus on the software supply chain? What makes it such a subject of current and critical risk? Like, why are we thinking about it in the final session here of an Amazon show? Because there are critical sorts of attacks that can be staged against the supply chain. It actually enables a new threat vector against our applications. And those can happen in two specific ways. First of all, exploiting the weakest link. In other words, I don't actually have to attack the production application because if I know how it's produced and I know an easily exploitable piece of that chain, I can simply attack that, embed my exploit into the application that gets produced. How do you exploit a suit of armor, right? That seems really hard. Armor's really thick and strong, and if I were to attack that head on, I would probably fail. But if I happen to know that the machine that produces the suit of armor has a critical weakness, I can exploit the machine and introduce a weakness into the armor before it even leaves the factory. So that's an example of exploiting the weakest link. There's also this concept of attacking once and infiltrating many, the idea being that these components that are interjected into our applications aren't just on a one-to-one basis, right? These open source dependencies and these CI pipelines and these source code managers can affect all of the consumers, all of the software products that are derived from them, that are touched by them. So I can, for example, infiltrate a commercial product like SolarWinds that I then know to be included in environments that are sensitive that I might then want to infiltrate as an attacker. The statistic Gartner came up with is that by 2025, 45% of organizations worldwide will have experienced attacks on their software supply chain, which is a threefold increase from last year. And we've seen several examples of this just in the past several months. Attacks like dependency confusion, which is the ability to allow or encourage a package manager when it's assembling its open source dependencies to actually choose a package that's already been exploited rather than one that's in a public repository that we actually know to be the software that we want to include. Typo squatting is another very common, similar to if you type in google.com but you leave out one of the O's, where do you end up? Well, it's not Google. You probably end up at a page that's trying to convince you that it is so that then some additional social engineering can happen. Typo squatting is also very prevalent in software supply chain attacks because I can simply register an open source dependency with one character sort of slightly transmogrified from the one I intend, relying on the developer to make a mistaken keystroke. Then the package manager goes out and grabs that piece of software rather than the one I intend. We've seen attacks like SolarWinds, I already mentioned, like CodeCove, which is a tool that examines the coverage or the best practices of code and is injected into many CI/CD pipelines. Because that piece of software was exploited, therefore every piece of code that had actually been sent through that pipeline all of a sudden contained additional risk, was liable to be attacked. We've also seen attacks like EventStream. EventStream was a JavaScript dependency pulled in by hundreds, if not thousands, of common JavaScript packages. The maintainer of the package needed help, right? He's an open source developer who was overwhelmed with the amount of interest in his product and approving pull requests. So he assigned merge privilege on the Git repo to a developer who had been very active in the project, had suggested a lot of his own PRs. That person turned out to be malicious and was able to interject some malicious code into that dependency, which then kicked off automated build processes for all of the applications that relied on it. and all of the applications that relied on those as dependencies. Now all of a sudden, that malicious piece of code has been injected into thousands of applications around the world in seconds, with no ability to verify along the way that that asset is the one that was intended. So the problem here is that software increasingly is complex and opaque, so it's difficult to trace and verify. There's this reliance on implicit trust in anonymous systems and maintainers. We simply assume that there are no bad actors involved. And there are always going to be weak links in the chain that are liable for attack. Especially when we consider that a lot of what touches software, the components of the supply chain, are not traditionally the purview of the security part of the operation. The CISO tends to care about securing the application that makes its way into production. The development environment is not their concern. It's written out of the security profile because it's too much to secure. And yet that is precisely the kind of weakest link problem. Because why would I attack the suit of armor if I could attack the machine that makes it and introduce those vulnerabilities by design? And of course, we're talking about this because of President Biden's executive order on improving the nation's cybersecurity, which specifically calls out for the first time this near infinite complexity in today's software that nobody has the tooling or processes to be able to track effectively. So if we take all of these together, we can isolate three distinct risk areas within the supply chain. We've got the inherent risk of compromised applications and dependencies that come through the supply chain. We've got potential compromise of the pipeline itself and the processes and the people involved that are actually conducting that build. And then we've got the compromise potentially of the dependencies of those bits and pieces, right? This is sort of a problem of infinite regression because every piece of software by definition has its own supply chain which involves other pieces of software. So that compromise essentially involves bypassing existing security measures, right? Don't attack the production application directly. Find a way to attack the build process itself, which actually leads to these cascading effects, because now all of a sudden your exploit is introduced in every application that relies on that piece of software or that mechanism of construction. So ultimately, what can we do about it? And I don't have great news for you here, but we can certainly start with the foundation, right? Identifying and capturing as much visibility into your software stack as possible. Leveraging the relevant frameworks in industry, such as HITRUST, such as the NIST cybersecurity framework, and things like CIS controls. And that gets you part of the way there, certainly. You can build upon that foundation by leveraging some of these emerging frameworks around supply chain security. Things like the Open Source Security Foundation has recently published guidance here. The Linux Foundation, which also supports the CNCF and others. We're also doing a lot of work at Snyk on this very problem as well. A lot of this starts with this concept called the Software Bill of Materials, or an SBOM, which functionally is an ingredients list about what's in your software. If I'm baking a cake, I need to know kind of what's the flour, right? What are the egg content? How much butter do I need to put in? So if I look at a product, I can look at the ingredients list, but that doesn't tell me the whole story because those ingredients need to be manipulated in certain ways. So if I start with the ingredients, that's a great step zero, but step one really needs to be to understand, well, what's happening at that point? Whose oven is that cake being baked in? And how many times was that door opened between when the cake was put in and when it was taken out? So we need to start with SBOM, but it's not going to be a silver bullet to solve this problem. We do need formal and machine-readable ways of communicating about software and their components and their dependencies and the risks that are involved in them. There's a raging debate in the SBOM community around whether that risk profile should be embedded in the data set that we're sharing about applications, given that the risks are changing all the time. A year ago, nobody was talking about Log4j as anything but a very useful piece of open source software. Now, obviously, that has changed. But what's important is understanding which of my applications actually have Log4j 2.11 or below, a vulnerable version that I would then need to remediate. So there's some of these emerging frameworks, including SALSA or SLSA, these supply chain levels for software artifacts. And again, it sort of provides a formalized approach to understanding where an organization is at with software security. Again, focusing on those three areas, the components of the application itself, the tools used to build it, and then ultimately the transitive dependencies of those tools that are used in the build process. CNCF has their own guidance as well, software supply chain best practices, again, focusing on securing everything from source code to the materials, the build pipelines, artifacts, how those artifacts are deployed, and et cetera. But again, let's start with the basics. Secure your code. Understand what open source dependencies you're using. Assess the security risk of them. The downside to open source is that, again, you're introducing code written somewhere else by someone in a different organization into your applications, and then you're deploying that in a way that can then be utilized by other applications. You're increasing the complexity of software and therefore of the risk. Containers are another source of vulnerability. Now everything the application needs is deployed within the app itself. It's no longer sent off to a server where there are other packages existing. Everything is self-contained. But that introduces another layer of risk here, right? Because I may not even know who built the container image that I'm utilizing, let alone the base image that that's based on, et cetera. Infrastructure as code adds another layer of problems here, because those same developers that are building the containers and building the applications are often configuring how they're going to be run out in the cloud. Often vulnerabilities inside something like a container or an application will have certain conditions they require for exploitability that can be met or not met by how they're being configured to run in the cloud. So infrastructure as code is actually recently recognized by the NSA as the top cloud security risk as we move here into the 2020s. And then, of course, your custom code, right? Developers are always going to be able to inadvertently or maliciously introduce something like a SQL injection or a cross-site scripting attack or a hard-coded secret. Securing pipelines is the other piece here, right? Ensuring the integrity of all aspects of the software used to build your software. Securing the factory itself. Vetting those third-party tools to ensure that their security standards are being applied consistently with those of your organization. Secrets management, obviously another big aspect of what's going on here. But source code management as well. Where is your source code stored? What are the security standards of that storage area to ensure you've got verification along the way? Again, these are sort of the table stakes aspects of supply chain security, beginning where we are now with no visibility into really any of these aspects. And of course, DevSecOps. Again, the DevOps revolution is really what led us to this level of complexity in software, but it's also the only tooling and processes that we have to get out of it. So integrating security early in that SDLC and automating as much as possible shifts that security burden from the artifact to the pipeline itself, so that you can ensure that what's coming out of it, by definition, is going to meet your security threshold and be deployable out into production. We have a number of resources here at Snyk that can help you with this transition to thinking about supply chain security, a white paper and a supply chain security cheat sheet, all available on our website, snyk.io. But the last piece I want to end on here, and I might go just a second over my time, is the idea of developer adoption, because none of this matters without the buy-in of developers who are building this software. And really, that's a question of people, process, and tooling as the critical areas for successful adoption of any software security program, but especially one as complicated as supply chain security. Development team maturity is important. We need appetite for change. We need to understand what that current tech stack and process is. The capacity for delivery is incredibly important here as well. We need to enable those teams to push changes through to improve the security of their applications. Embracing both top-down and bottom-up security, empowering developers to take ownership of what's going into their applications, rather than simply say, I trust that because it came from a place and I don't have any other options otherwise. Enabling collaboration and building security champions among that developer population. And education, ensuring that they are up to date on what the latest threat vectors are, on the risk being introduced by increasing the complexity of their software. Process improvements can include, bringing developers in to any changes that might impact the software building process. Making the right path the easy path is a big part of this as well, because developers will always take the easy path, right? Their jobs are really hard. To getting useful applications into production is an incredibly complex task, which we make more difficult with security. We need to pave the road and encourage developers to make the secure choice also the easy choice. And then finally, visibility and transparency. Developers are in an anxious position because the weight of these organizations is on their shoulders. And the only way to enable them to communicate and collaborate around the potential risk is to create a cultural environment of transparency that encourages them to speak up. Developer values can be integrated with gamification to encourage friendly competition among teams and so forth to ensure they're limiting that risk as much as possible. But most importantly, just understanding the concept of all of these new risk vectors introduced into modern cloud-native applications. Tooling is a big part of this as well, certainly, but we're still in an environment where we're just getting to table stakes around things like code scanning, software composition analysis, infrastructure as code testing, and more. So the tooling will continue to evolve, but organizations need to be thinking now about how they're going to tackle these supply chain concerns in the future. And ideally, this is done without overwhelming developers, right? When introducing new solutions, it needs to be gradual. We need to ensure that those capabilities are growing over time, but that developers have the awareness and the reasoning and documentation. Because you can't tell an engineer to do something, but you can give them the reasons for why they should and allow them to make their own decision. So those rollouts need to be slow and gradual, but ultimately reliant on the goal of increasing transparency across the board about what's going into our software. And finally, automating everything, right? The only way out of these problems introduced by DevOps, unfortunately, is more DevOps, more automation, more shifting left into the developer workflow. So that's about all I have. I did want to give a quick plug for Snyk. Again, so now you know, developer security platform focusing on empowering engineers to make better decisions about what goes into their applications in their workflow when they can have the most impact. We have a number of AWS security certifications as well as being available on the AWS Marketplace. I would normally say please come see us in the booth, but we just tore down the booth. But please come see us after the talk if you're interested in learning more about Snyk. Over my time here, but if there's a quick question, be happy to take that here before we wrap things up. All right, not seeing anything. Thank you, everyone. Again, my name's Clinton Herget. I am an engineer at Snyk. Would love to talk about anything supply chain software security related. Thank you all. Hope you enjoy the rest of the show.